linear functions. So last one, R.5, non-linear functions. So here's one that we already looked at, f of x equals the square root of x. Can anyone tell us how to find the domain of this function? We had 2 examples last time. What do I have to write? Anyone, please?
X has to be greater than or equal to 0.
Thank you, Samuel. Very good. Of course. So the domain of this function is 0 to infinity, bracket because of the equal symbol. And the graph, and we should remember this graph, very easy graph. It's not a straight line. Please don't think it's a straight line. This is the graph of the square root of x. From the graph, can anyone else give us the range of this function?
From 0 to infinity.
Thank you very much, Ilya. Thank you. Nice function. Good. Let me move on. Next page. So here's another one that we looked at already. Let's refresh our memory. What is the domain? Oops. What is the domain of this function?
All real numbers.
Right. Very good. We wrote last time polynomials are defined on all real numbers. Friendly functions. Thank you very much. And we remember the graph. It's an easy graph.
It's parabola.
Yes, it's a parabola. Very good. This is it. So this is y equals x squared. Good. Another one. F of x. Of course, we can have other more complicated situation, but this is the simplest possible. The easiest thing to, the easiest quadratic function. Okay, this is the absolute value. Please remember is also called the v function. Very easy to remember. And yes, it has domain all real numbers. I can put in here anything I want. And here's the graph. Like the v function. Bisects, these two are equal. Bisects the quadrants. So this is y equals the absolute value of x. Very easy function. Okay, so let's look at one more. This is a more complicated function, and we're going to work on it later on in this course. We're going to graph complicated ones, not this one. Can anyone give us the domain of this function? We analyzed the domain some time ago, last week. What is the domain? What is the value, or maybe values that the function cannot, I cannot plug in the function?
It can be anything besides negative and a 0.
It can be negative. 1 over negative 3 is negative 1/3.
X is not equal to 0.
Just not equal to 0. Thank you very much. So then I will write negative infinity to 0, parentheses, signifying not 0, union, this means or, 0 to infinity. And the graph is slightly more sophisticated than everything else we've seen so far. It's a very nice graph, however. It's this. Notice that it does not touch the x-axis and it does not touch the y-axis. So this is 1 over x. Y equals 1 over x. Yes, we can plot it with point. Yes, go ahead.
Question. So is domain x values? And
Always.
ring
Yes.
y values?
Yes.
Oh my God.
Yes. 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 Yes, we discussed that in in R.3. Do you need me to go back and look at a particular problem?
No, I don't want to hold the class up. I'm just, lagging, but okay.
So let me just show that in, so this was it actually here in R.3. So when we found domain and range, we looked at, it's okay to review. I'm sure it helps everyone. Unless I'm logged out. Maybe it will open, please, today. It will open. Now let me look at the page number so I can jump directly there. What page is that? What page is that? What page is that? 32. So again, let me look for my keyboard. Okay, so remember last time we identified from a graph domain and range, and we said the domain is between the leftmost point, -4, till the rightmost point, +3. And the range is from the lowest y value, -5, all the way up, 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 till 4. Is that okay?
Yes.
For example, for this problem, it's between -5 all the way to +4. And for the y values, meaning the range, between -3, yes, 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 to 2. Above 2, the function doesn't exist. Below -3, the function does not exist. So the range is between -3 and 2. Is that better?
Yes, and I don't know why I just didn't click.
That's
before,
okay.
but
That's okay.
Okay.
That's why I'm asking kindly, please rewatch the videos. It will start clicking because that's the only way. Okay, so now I would like us to review exponential rules. So I don't know why I stopped sharing. I should have not. I want to go to page 60, if I can get to my keyboard. Okay. So I don't really need us to go through all these explanations because, or graphing unless you want to. This is all about transformations, shifting left and right, up and down. If you want, we can. What I would like to do right now is, because this is very important, I would like us to work on the exponential rules. Okay? Rewrite each of the following as an equivalent expression with rational exponents. So I need to explain this. This is what I would like to work on for a minute. Now, we can continue with the domain. Determine the domain of each function. We've just done that a few minutes ago with a rational function and a radical function, but we can review and do that. But I would like to explain the radicals and how they change into rational exponents. Okay, so then we go back to the rest. So allow me to refresh your memory on exponential rules, especially the correspondence between, so this is my page 7. So exponential rules, and then we'll pick the problems you like. And also radicals. So what's the connection between these two? Are we talking about exponential rules or are we talking about radicals? Both. Because a radical is also an exponential rule. I mean, a radical, it can be written as an exponential expression, and depending on the exponent, I can write a radical. So there is a big connection here. So if I have, let's say, x to 1/2, every time the exponent is a fraction, exponent is a fraction. When the exponent is a fraction, then the expression is a radical. If the exponent is x to the third or power 3, this is not a radical. But every time the exponent is a fraction, positive or negative, it doesn't matter, that expression changes into a radical and vice versa. The denominator is the index, and this is the only one we do not write. I put it as a shadow in there. And the power, the numerator is the power of 1, in this case, the power of x. So what is the general expression? Let's say x to m over n. I know you don't like m and n because mine are weird. Okay, sorry about that. So let's say a over b. So this is, the denominator is the index. The numerator is the power. Okay? And vice versa. If I have the square root of x, I will write x to 1/2. 1 over 2. X to 1 over 2. Maybe you do remember this, maybe you don't remember, maybe you are bored with this already because you know this. The other rule that I like to mention here is, let's say x to negative 3. X to negative 3 is 1 over x to the third. When you see something like this, please don't say it's negative. No. If the power is negative, this reduces or changes into 1 over that expression to power positive. What if I have 1 over x to negative 3? When I bring it up, I change its power from negative to positive. If it's in the numerator, I change it to the denominator and becomes positive. If it's in the denominator, it goes to the numerator and becomes positive. Okay, so this was a quick refresher on what we need here. And now let's choose from 45 through 54, whatever you think we should look at. If not, I will choose.
Can we do 47?
Yes, let's start with 47. Okay, 47 is y to 2/3. And they say present the radical notation. Fine. So remember, every time you see an exponent that is a fraction, that means a radical. So let's identify the index. Can anyone give us the index here?
3.
Yes. Can anyone? Of course, it's silly. If 3 is that, then obviously this must be 2. It was a silly question, right? What if I now want to go backwards? Let's say I have the 5th root of y to the 3rd. What will that be? Of course, the base is the base. But what about the power? The power must be a fraction. Why it must be a fraction? Because I have a radical. So when I go back, the power has to be a fraction. What fraction will that be?
Y 3 over 5.
Yes, this is the number, and this, the numerator, and this is the denominator. Exactly. Who was that? Thank you.
Julia.
Thank you. Okay, I'm going to share my screen. Now let's look at the negative. So let's choose a negative here. Any negative exponent.
49.
49. So for 49, you chose t to negative 2/5. Good. So first of all, remember that every time I see a negative exponent, and it's not in the denominator, it's like this, I have to write 1 over t to 2/5. And now let's change t to 2/5 into what? Because the power is a fraction, I know where that is coming from or what it represents. What does it represent?
One over t to the 2/5.
Just mimic this. We looked at y to 2/3. and we wrote the cube root of y squared.
Change the fraction to a radical.
Good, I'm ready.
And then it's 5, and then it's t to the second t squared.
Very good. 1 over the 5th root of t squared. Awesome. Is this okay? Any questions? Please. Any questions? Okay, I'd like to continue here. Do we want to choose any domain? If you want to choose any domain, please do so.
Can we do 72?
Yes. So let's look at, I'm on page 8, and we picked 72. And we have f of x equals x to the 4th plus 7 over x squared plus 6x plus 5. Good? Excellent. Okay, so what type of function is it? Because if it's polynomial, domain is all real numbers. If it's absolute value, depending on how it looks, absolute, all real numbers. What type of function is it? Well, let's take a look. Is it this? Is it this? Is it this?
The fourth one.
Of course, it's a rational function. So let's write, very important, rational function. Because it has x in the denominator. Good. So what is the problem or potential problem with rational functions? What could go wrong with rational functions? Anyone I haven't heard from? Or maybe Ezra. I haven't heard from Ezra. If you're speaking, you're muted.
Can you repeat the question?
Yes, yes. What could go wrong with a rational function?